So again, we were really surprised in that we found that booty eels were not associated with topography at all. That includes that red-tailed hawk. What I should say here is that Hawk Ridge at that southwestern terminus of Lake Superior counts sometimes over 200,000 broadwing hawks. And broadwing hawks migrate in really spontaneous episodes. And unfortunately, when we were out on the North Shore, we missed those episodes. I think we hit one, but we happened to be doing the terrestrial part and we're watching broadwings go over. So this does not include broadwing hawks, but it does include red-tailed hawks, rough-legged hawks. They were not associated with topography at all. Some raptors were associated with proximity to shoreline. Kestrels, sharp-shinned hawks, more of those birds were found along the shoreline, but this funneling effect we only found for eagles. So only golden eagles and bald eagles we found were actually quote-unquote funneling to Duluth. And to read this schematic, I guess, this is distance from Duluth, so 0 being Duluth, 250 kilometers being up in Grand Portage near Canada, and this is distance from the shoreline moving inland. Again, these are our sites. There are sites here too, but there weren't enough golden eagles to show just in this graph. And you can kind of see an increase in golden eagles as you get closer to the shoreline and closer to Duluth.
Anna, could you just explain that last bullet again real quick? I wasn't following it.
This guy?
No, the last bullet, that the eagles are the only ones that show funneling.
Only eagles showed, I probably didn't explain this well enough, so that diversion line, how the idea of, well, you're familiar with former counter at Hawk Ridge. The idea is that birds hit a diversion line, being the North Shore of Lake Superior, and you keep getting this influx, so you expect to have more birds near the shore, more birds near Duluth, and basically at Hawk Ridge you're seeing like the entire migration coming right at you, especially on like northwest wind days, right? So that's what we expected to find as well. And it's only eagles that were actually showing that funneling movement to Duluth. Does that make sense? I may have cruised through that too fast.
What could that mean? Is that to say then that the other birds, if you traveled up the shore further away from the numbers would be relatively the same?
Yep, you can see just as many birds in Grand Marais as you could in Duluth, which in fact we did. And I don't actually go into this in much detail in this talk, but I would be glad to talk more about some of the things that we found. Because I was going to try to focus on the little birds. So moving on to the non-raptors, again, these are mostly passerines. What we found is that early season migrants were not associated with topography at all. Those are mainly those long distance migrants. But when we looked at short distance migrants, or the late season migrants, actually a lot of them had stronger associations with topography than the raptors did. And several of them show that funneling, which I thought was fascinating. This is all the late season passerines. There's probably about 68,000 birds in this data set, and you can see them increasing as they get towards shore and towards Duluth. Okay, and then the last piece of spatial pattern that we wanted to look at was flight height. So we put these birds in flight height categories from below the canopy, which we didn't analyze because we ended up realizing they were really hard to see below the canopy. Canopy to 100 meters, 100, 500, 500 and above. One of the questions I get a lot is, well, how did you know how high these birds were? I didn't know exactly how high they were. But if you remember back to that data sheet that had the dots on it, we used topographic maps to collect the data, and a lot of the times we were actually up higher than the birds were moving. So we could have a relative guesstimate as to how high these birds actually were over where we first saw them on the landscape. And just a couple things I want to point out. These are just 2-letter codes for the raptors over here, and then raptor groups. All the passerines, and then some passerine groups. All the birds are moving within canopy to 100 meters. And when we started this study, we were looking at that airspace category because of the potential for wind turbine development on the North Shore, which hasn't happened and may not happen. That's still yet to be determined. But you can see that all of them move in that airspace, and then there's various other heights these birds are moving at. And of course, for the implications are, this is the airspace where development occurs. A lot of development occurs. Okay, so how are non-raptors using the North Shore? With the information that we collected, we found topography and line cover really didn't influence the distribution during stopover. And one of these reasons may be, and Rebecca talks about this, the North Shore may be considered that full-service hotel, right? These birds, they're forced to land, if you will, to stop, and everything is provided so they can distribute. That could be one possibility. A lot of the same birds that we recorded stopping in the habitat, we also recorded actively moving. So the birds are moving. Another potential thing that might be happening on the North Shore is what's called a flying forage strategy, where the birds are continuing in a semi-migration direction, but they're able to forage and then fly and forage and fly because the habitat is available for them to do that. So we may have been recording them not only stopping and foraging, but actively moving during both these parts of the study. And they're moving in patterns. One of the things that I think is really interesting about this is that when we talk about airspace movement and conservation implications, where a lot of us are talking about raptors, but there is a pattern in which a lot of the passerines are moving in airspace as well, at least on the North Shore. And I would suggest that a lot of those patterns have been overlooked. And I'm going to use the rusty blackbird as an example. So for those of you who don't know this little guy, his population has declined by 90-some% since the 1960s. That's also one of the highest declining bird species, boreal bird species. It's a short distance migrant. And the Great Lakes kind of sits right between its breeding and overwintering area. 2011, the folks at Hawk Ridge, who are now counting non-raptor movements, counted over 23,000 rusty blackbirds moving through Duluth. So some of the information from our study, 85% of blackbirds, of which rusty blackbirds fall in this category, were moving within 100 meters of the tree canopy. They were moving within the first 3 hours after sunrise, and they showed a little bit of that funnel effect. A lot of the birds were found near shore, and the highest numbers of birds were found as we got closer to Duluth in the airspace. So there are some patterns in how these birds are moving through the air. So in summary, so this was the first study to kind of quantify how birds were using a corridor over a very large area. It's over 2,000 square kilometers. And it's heavily used by migratory birds. The migratory non-raptors, mostly the passerines, were evenly distributed in the habitat, the salvador habitat, except for this fancy thrush, which we found that topographic pattern for. The migratory non-raptor patterns, there are migratory non-raptor patterns, however, in airspace, especially for those short distance, the late season migrants. And that includes funneling. And I think you all know the implications. With 50% of the U.S. population moving to coastlines, there has to be infrastructure to support that development, and includes everything from buildings to the windows to the cats, to the energy infrastructure. This is just a picture of, maybe you have an updated one, do you?
Yeah.
I'll let you talk about it. Okay. And the Obama administration in the past has been very interested in the Great Lakes as far as wind goes. And this is a map from 2008 that looked at Minnesota's North Shore wind resources. Although it doesn't look at feasibility, it looked at wind consistency and power, and did find that a lot of the North Shore there was a potential to build wind turbines on the North Shore. Okay, so we're talking about cumulative impacts here, not only when we look at stopover habitat, but also the airspace habitat and airspace surrounding these stopover areas. One thing that I'm interested in, that I feel like the migration community is moving towards, is not just looking at specific groups of birds or species of birds and conserving them during migration, but looking at the migration phenomena as a whole. It's a critical life stage that has profound effects on survivorship, and there's more and more data and research coming out on that. I found this really interesting. Each spring, 30,000 tons of songbirds will migrate through the U.S. They'll consume upwards of 10,000 tons of insects per day. You know, what does that mean for our forest health, for our agriculture health, if that were to disappear? Something to think about. And I always like to bring this up, for those of you who don't know Captain Perkins. So he was a captain in the 1940s and 50s. I know some of you know this, and you can correct me if I don't have this correct. A captain that sailed with U.S. Steel over most of the Great Lakes, an amateur ornithologist, loved birds, and you know, the birds would land on his ship during migration. He started, at every port, started buying trees and shrubs to support the birds on his boat. And what fascinates me is that, I mean, not only the species list that he has, but that he was able to tell his crew when they're about to enter a corridor over the lakes. Wake me up when the birds start hitting, that we're gonna enter it. And this kind of goes against the general thought about a huge broad migration over bodies of water. This is a map that Captain Perkins drew of where he thought the major migration corridors were over the Great Lakes. And this is Lake Superior. So something to think about, and one of the things I think would be really valuable for Lake Superior and migration, if these corridors do exist, then it tells a lot about which stopover areas or coastal areas are also important. It would be great to have ships out there with radar or acoustic or
Christmas trees.
dreams and Christmas trees. You got it. And so with that, I will take any questions.
We can allow just a couple of minutes for questions, maybe one question, and then we'll have to save others for afterwards. So who's going to be the lucky recipient of the answer? You're first.
When you set up your sites, you know, coast and in 3 sites, coast to coast.
Yeah.
So were those placed on North Shore streams or not necessarily? Were those, some of them look like they were on stream corridors?
No, not necessarily. It was wherever we could find 3 places that we could actually see the airspace.
And,
Yeah.
oh, I'm sorry, go ahead.
Rebecca.
So one of my hypotheses about why birds during the day avoid coastal areas, because most of the birds that are coming on land want to get away from the coast. And that's true for the Gulf Coast. Frank Moore has been studying birds that are the end of the distribution. The majority of the birds go further inland.
Inland, yeah.
And my hypothesis for our areas in the north is that I think that insect activity, because these birds are still highly insectivorous throughout most of their migration, there's still a lot of food abundance for them, is delayed on a day. The insects aren't as active because the coastal areas might be a little cooler. And I just wonder if anybody's ever looked at that as, you know, food availability is not just that the insect's present, but is it detectable by the bird? And so I'm thinking that one reason, particularly during cold fall mornings, is that birds avoid these coastal areas, is that food is less detectable, makes for a less efficient foraging.
That might be. Dave Ewert, who unfortunately isn't here, did a study kind of to look at that on Lake Huron's coastline. And in the spring, they found that the birds were on the coast because of the midge hatch. In the fall, it was less prominent, but they still found that someone else might be able to correct me if that's incorrect. I mean, it's a great question, and as far as the North Shore of Lake Superior itself, none of this stuff is really been looked at.
Yeah.
But that could
It
be.
just seems like mornings, it might be tougher to find an insect along the shoreline.
That
than
makes
it would
sense.
be-
And actually, and one of the hypotheses that we had, but we haven't looked at it, is, you know, we saw those Swainson's thrushes at high elevations. So what spot on the North Shore gets the morning sun? The highest
Exactly.
elevation.
Yeah,
You know,
exactly.
so active insects, and I think that'd be a fascinating thing to look
Yeah.
at.
Yeah, exactly.
That's really what we're seeing along Lake Huron. It's the exact opposite. The heaviest numbers, even early in the morning, is right on the shore.
Really,
But it's
yeah.
higher in the trees because that's what the sun's first hitting.
Oh,
in the
really?
fall.
Yeah.
And then the birds come down.
So it could be insect activity that's
It could be
driving
insect
it. Yeah,
activity.
yeah.